light amplification by stimulated emission of radiation. Okay. Okay. This phenomena, stimulated emission, these phenomena play an important role to produce high intensity monochromatic light. Okay. So basically, to produce that laser light, this phenomena, stimulated emission, that phenomena is playing important role. Okay. So laser is nothing but a high intensity monochromatic radiation. Monochromatic, inside bracket you can mention almost. Laser is nothing but a high intensity monochromatic electromagnetic radiation. So that light produced by laser has some remarkable characteristics. Okay, the light produced by laser has some remarkable characteristics. So we'll discuss that characteristic of laser light. Characteristic of laser. Okay. So first, the directionality. Okay. The light produced by laser, you can mention that light produced by laser is highly directional. The light produced by laser is a highly directional. Why? Because of low spreading of or low divergence. Okay. Why? Because low spreading or low divergence. So light produced by laser is highly directional. So if I give an example, suppose you have a ordinary torch. Suppose you have an ordinary torch. Okay. This is the ordinary torch. And on the other hand, you have a laser. On the other hand, you have a laser. This is your laser source. Okay. Now, light produced by laser. This is the light produced by laser. Okay. If you see the spreading of this layer of this light that light produced by ordinary source or ordinary torch, if you see the spreading of this light from 2 kilometers away from source, then the spreading will be very large. For ordinary case, spreading will be very large, and the diameter of this outgoing beam at a distance of 2 kilometers, the diameter will be approximately 2 kilometers. Now you can imagine for ordinary source that how much spreading it is. The spreading of light is very large for ordinary torch or ordinary source. However, if you have a laser source, suppose that light is emitting from this laser. Now, if you want to that measure the spreading of this light from 2 kilometers away from source, okay, from 2 kilometers away from source, then what you will notice that the diameter of this beam will be less than 2 centimeters. Okay, so why this low divergence, that I'll tell and I'll discuss when I'll discuss that phenomena that is known as stimulated emission. Okay, so we can understand that how it can be useful, because it has very less divergence or very less spreading. But for ordinary torch or ordinary light, the intensity will be decreasing very rapidly. Why? Because of very high divergence. So one of the remarkable property of laser light that it has very low divergence, or it is highly directional. Is this clear what I'm saying?
Yes, sir.
So you can mention in that directionality itself that laser light can travel long distance without much spreading. Laser light can travel long distance without much spreading. Even suppose you have a earth. Suppose you have a earth noted by E, and you have a moon, okay, noted by M. Now, if you send laser light from earth to moon, then if you send laser light from earth to moon, you will get that spot size of this laser beam only few centimeters. Only few centimeters that spot size will be. Why? Because of highly directionality of this laser beam. So if you send that laser light from earth to moon, the spot size of this beam will be on the moon, it will be only limited by few centimeters. Why? Because of its highly directional property. Is this clear what I'm saying?
Sir?
Yes.
Sir, can you repeat once more, sir?
Yes, I'm repeating. Suppose you are sending that laser light from earth to moon, okay? You know that distance, how much it is far away from, right? That moon is far away from earth. If you send that laser beam from earth's surface to moon, the spot size of this laser beam will be only limited by few centimeters. The spot size of laser beam will be only limited by few centimeters. Why? Because that laser light can travel long distance without much spreading. स्पॉट साइज छोटा क्यों है? क्योंकि लेजर लाइट का जो स्प्रेडिंग है वो कम है. इफ यू सेंड लेजर अदर लाइट, इट कैन नॉट ट्रैवल दैट मच डिस्टेंस. यहाँ से अर्थ सरफेस से आप मून में ऑर्डिनरी टॉर्च से लाइट सेंड नहीं कर सकते, बट यू कैन सेंड दैट लेजर बीम एंड दैट स्पॉट साइज विल बी वेरी स्मॉल, only limited by few centimeters.
Sir.
Yes.
Laser light is emitted at that time also. It is spot size is of few centimeter only, na?
Yes.
Emitted.
Yes. So because of this highly directional property, laser light can be used as a pointer also. You can mention that because of high directionality of laser beam, you can use this laser as a pointer. Is this clear what I'm saying? And why it is highly directional, that I'll tell. I'll discuss this in detail. Okay. The second property is high intensity. High intensity. Noted by high. So laser beam, actually laser light is having very high intensity. There are basically two type of laser. One is known as continuous wave laser, CW laser. Okay. CW means continuous wave laser. The intensity of continuous wave laser is actually 10 to the power 5 watt per centimeter square. On the other hand, there are another kind of laser known as pulse laser. The intensity of pulse laser is very high. The intensity of pulse laser is very high. And if you see that intensity of this laser, it is of the order of 10 to the power 22 watt per centimeter square. Okay. Now, what is continuous wave laser and what is pulse laser? Okay, you may ask me. So
in pulsed laser, pulses are released.
pulse, sir.
Pulse, yes, sir. Pulsed are released, sir, in the pulsed laser.
Exactly. So if you see that output versus time plot, you have one kind of laser that is known as continuous wave laser, and another you have pulse laser, right? So if you measure that output power, P out, as a function of time, here also, if you see that output power as a function of time, okay? So in continuous wave laser, you will get, I mean, always at all, every time you will get power. I mean, okay. So suppose this is suppose you have a continuous wave laser, so you will get all time it will emit that light. Did you get what I'm saying? So output power will be continuous with time. I mean, did you get? But that output power will be very small. That amount of output power will be small. On the other hand, the output power for pulse laser, it will be discrete in nature. It will be discrete in nature, but the amount of power will be very high as compared to continuous wave laser. Okay. So I'm giving example. Suppose you have one continuous wave laser, another you have a pulse laser. Continuous wave laser में क्या मिलेगा आपको? हमेशा लाइट मिलेगा, but उसका इंटेंसिटी क्या है? कम होगा. And you can see here. Okay, 10 to the power 5 watt per centimeter square. On the other hand, in pulse laser, you will not get intensity always. You will not get light always. कैसे मिलेगा आपको? सपोज मान लो एक शटर होता है, एक्चुअली लेजर के सामने एक शटर होता है, तो शटर खुल गया, ह्यूज अमाउंट ऑफ लाइट पास हो गया, फिर शटर बंद हो गया, फिर कुछ मिली सेकेंड बाद शटर को खोला गया है, सडनली आपको बहुत सारे लाइट मिला, इंटेंसिटी मिला है ना? तो क्या होता है, शटर को सपोज मान लो 5 मिली सेकेंड शटर बंद हुआ, फिर खोल गया, आपको सडनली बहुत पावर मिल गया, फिर 5 मिली सेकेंड बंद हो गया, है ना? सो विल नॉट गेट फॉर 5 मिली सेकेंड, यू विल नॉट गेट लाइट. सडनली उसको ओपन किया गया है, सडनली आपको बहुत सारे हाई इंटेंसिटी लाइट मिल गया, फिर उसको 5 मिली सेकेंड के लिए बंद किया गया है. इस वे में काम करते हैं आपका पल्स लेजर. एंड इन रिसर्च बेसिकली वी आर यूज दिस पल्स लेजर. In research, we basically use this pulse laser to deposit that thin film. Okay. Why? Because it has very high power or intensity. Can say yes.
सर अगर हम कंटिन्यूअस वेव लेजर में भी ऐसे ही शटर लगा दें, बंद कर दें, फिर खोल दें, तो क्या हमें पल्स लेजर जितनी इंटेंसिटी मिल जाएगी?
Yes, it depends upon type of laser. So basically, you will get, obviously you will get that pulse laser, but yeah, intensity, to increase that intensity you have to manipulate other parameter also. Yes, but for continuous laser, if you use that pulse laser, then you will get pulse laser. Sorry, if you use shutter in front of continuous laser, you will get pulse laser. जस्ट क्या करना पड़ेगा, शटर को ओपन करना पड़ेगा कुछ टाइम के लिए, फिर बंद करना पड़ेगा, फिर ओपन करना पड़ेगा, बंद करना पड़ेगा, है ना. And I'll tell you why that actually that intensity for pulse laser is high as compared to continuous wave laser. That I'll tell you.
तो सर हम कन्वर्ट कर सकते हैं एक दूसरे से, लेकिन इंटेंसिटी जो पहले थी वो इतनी ही रहेगी ना.
नहीं, देखो एक्चुअली कैसे काम करता है. आप देखो पल्स लेजर में इंटेंसिटी आपको ज्यादा क्यों मिल रहा है, व्हाई यू आर गेटिंग हाई इंटेंसिटी, बिकॉज दिस इज ऑल अबाउट दैट नंबर ऑफ फोटॉन्स. ठीक है, जैसे आपका सपोज मान लो आपके पास पल्स लेजर है, तो एक तो आपका कैविटी होता है, एक आपका क्या होता है, कैविटी होता है ना, और इसमें आपका शटर लगा देते हो, सपोज दिस इज योर शटर. तो ये जो लाइट है, आप सपोज मान लो 5 मिलीसेकंड के लिए आप बंद कर रहे हो, आप जाने नहीं दे रहे हो यहाँ पे जो फोटोन है, ठीक है ना. तो नंबर ऑफ फोटोन्स तो यहाँ पे बढ़ गया ना. सपोज मान लो ये कैविटी है, जहाँ पे आपका कैविटी, जहाँ पे आपका बेसिकली फोटोन्स क्रिएट हो रहा है. I'll tell you that mechanism how that basically laser light produce. बट जिस टाइम आपने सपोज मान लीजिए अपना शटर बंद कर दिया, उस टाइम क्या हो रहा है, आपका नंबर ऑफ फोटोन्स एक्चुअली इज इंक्रीजिंग इनसाइड दैट कैविटी, है ना. तो जैसे आप खोल दोगे तो क्या मिलेगा, आपका नंबर ऑफ फोटोन्स इमिटेड दैट विल बी हाई. व्हाई, बिकॉज यहाँ पे आपका बहुत सारे नंबर ऑफ फोटोन्स क्रिएट हो गया यहाँ पे. ओके, सो दैट्स व्हाई you will get high intensity. But yes, if you have a continuous wave laser and if you use this shutter to produce pulse laser, obviously intensity or power will be high. Is this clear what I'm saying?
Sir, means I'm actually that girl what she asked, I'm asking about that if we use a continuous laser and we convert it into pulse laser, okay, by shutter on and off technique, what will be the intensity? Will be it 10 raised to 5 or will be as previous, means will it change 10 raised to 22 after converting?
Obviously it will increase that intensity.
Okay, because for time storage. Okay.
हाँ, क्योंकि आपका नंबर ऑफ फोटोन्स जो है कैविटी में आपका ज्यादा हो गया है ना. तो कुछ फ्रैक्शन ऑफ फोटोन्स क्या होता है, बाहर जाता है, जहां से आपको लेजर लाइट मिलते हैं, है ना. आपका एक्चुअली जनरेटर कहाँ पे फोटोन और लाइट कहाँ पे प्रोड्यूस हो रहे हैं, फोटोन इनसाइड कैविटी, है ना. आप कुछ टाइम क्या कर रहे हो, आप फोटोन्स को जाने नहीं दे रहे हो बाहर, तो ऑब्वियसली यू हैव ए हाई एम्प्लीफिकेशन ऑफ लाइट इनसाइड कैविटी. जैसे आपने उसको खोल दोगे, ऑब्वियसली कुछ परसेंटेज ही आपका, कुछ परसेंटेज ऑफ फोटोन ही बाहर जाते हैं कैविटी के, तो नंबर आपका कुछ नंबर ऑफ फोटोन इनसाइड कैविटी बढ़ गया है और उसका कुछ परसेंटेज ही बाहर जाएगा, तो ऑब्वियसली दैट परसेंटेज विल बी हायर व्हेन यू आर यूजिंग पल्स, तो सॉरी दैट शटर, है ना. शटर जब यूज करोगे, नंबर ऑफ फोटोन्स इनसाइड कैविटी विल बी इंक्रीज, सो ऑब्वियसली आउटपुट आपको ज्यादा मिलेगा.
Thank you, sir. Got it.
Okay, and because of this high intensity that of pulse laser, this laser is basically used in this research to produce or to manufacture that thin film, so it can have ability to evaporate that atoms from solid. Okay, then another property of this laser, that is number 3, spectral purity. Spectral purity. Spectral purity means that spread in lambda, delta lambda for laser light, delta lambda for laser light, it is very small. It is 10 to the power minus 6 angstrom only. Spreading in wavelength is of the order of 10 to the power minus 6 angstrom. Okay. So ideally, suppose you have a monochromatic light. Suppose you have a monochromatic light, then can you please tell me what will be the value of delta lambda? Delta lambda कितना होनी चाहिए?
So ideally तो 0 होना चाहिए.
It should be 0. For monochromatic, delta lambda should be 0. For monochromatic, right? But you can imagine that delta lambda is of the order of 10 to the power minus 6 angstrom. 10 to the power minus 6 angstrom. You can imagine how much small it is actually, right? It is
0.1
almost,
femtometer.
it is almost tends to 0. That's why this laser light is called almost monochromatic. It is called almost monochromatic. It is called almost monochromatic. Now, what is delta lambda? If I ask you what is delta lambda actually, okay. So delta lambda can be defined from this plot itself.
Hello, sir.
Yes.
The board is not clearly visible. It's black.
Is it true for all?
No, sir. It is visible.
आपका नेटवर्क का शायद इशू है. Can you please check? I can see that it is visible.
Yes, sir. Properly.
So now how will understand the delta lambda actually? So now if I measure that output power of laser P out as a function of wavelength, then I'll compare that output power as a function of wavelength for ordinary case. So ordinary case you will have this kind of plot. This is for ordinary light. Okay. So it means that whatever output we are getting from ordinary source, that output can have many number of wavelengths. है ना? Many number of wavelengths that it is possible. जो आउटपुट आपको ऑर्डिनरी सोर्स से मिल रहा है ना, आउटपुट पावर, it can have many number of wavelengths. Why I'll tell you that also. But in case of laser, if you see that output power as a function of wavelength, then it will be looking like this only. This is for laser. And what is delta lambda actually? Delta lambda means full width at half maxima. So this width actually, this is delta lambda. When that output power is maximum value का जो 2 है P max, इसका P out you can mention here that it is actually, suppose this is your P max. So this will be actually P max by 2. Why this kind of behavior is observed for laser light? On the other hand, you have broad spectrum for ordinary light. So that to understand this,
Monochromatic nature.
to understand this, we have to draw that how that basically ordinary light we are getting. So suppose you have
P maximum by
P max.
P maximum.
So delta lambda is what basically? Delta lambda is full width at half maxima. Suppose this is the maximum P max. So width of this peak at a value of P max by 2. है ना? ये जो है आपका P max. Okay, now
सर ब्लर है ये ना, दिख नहीं रहा, ब्लर है थोड़ा.
is this सबको नहीं
सर
दिख रहा?
Clear, sir.
बोर्ड राइटिंग इज ब्लर.
Clear, sir.
Can you please check your network? I think there is some network issue maybe. Okay, so to understand that why that ordinary light have many number of wavelength in output power. On the other hand, you have a laser light, it has only few wavelength, or you can say that spreading in wavelength that is very small. So to understand this, we have to understand that mechanism of production of ordinary light. So how actually ordinary light is produced? Suppose you have a nucleus. Suppose you have to understand that atom. So you have a nucleus, then you have a atomic or electronic orbital. So suppose this corresponds to n equals to 1, this corresponds to n equals to 2, n equals to 3, and so on. So to produce this ordinary light, you have to excite that electron. So suppose you have a excited electron at n equals to 2, n equals to 3, and so on. ठीक है? अब कैसे ordinary light produce होता है? जब there is a transition of electron from a higher to lower state. So when there is a transition from n equals to 2 to 1, you will get one wavelength that will be lambda 1. From 3 to 2, you will get lambda 2. 3 to 1, you will get lambda 3. Sorry, and so on. Okay, so in that way, actually, ordinary light is produced. Did you get what I'm saying? So you have many electronic transition is possible, and each transition actually have many different distinguished wavelength. ठीक है ना? So suppose मान लो इलेक्ट्रॉन आपका n equals to 2 में है, जब n equals to 1 पे जंप करेगा, इसका जो वेवलेंथ होगा डिफरेंट होगा एज कंपेयर टू जब आपका n equals to 3 से 2 पे जंप करेगा और n equals to 3 से 1 पे जंप करेगा. So in that way, actually, your ordinary light is produced. So you can understand now that it can have many number of wavelengths is possible. That's why you are getting actually that broad spectrum. But on the other hand, how that laser light is actually produced? Laser light is only produced because of electronic transition from fixed level, that is when there is a transition from E2 to E1. मतलब लेजर लाइट कैसे प्रोड्यूस होता है? दो फिक्स्ड एटॉमिक लेवल का जो ट्रांजिशन है, इलेक्ट्रॉनिक ट्रांजिशन है दो लेवल के बीच में, ये लेवल डिफाइंड है लेजर लाइट के लिए कि भाई आपका लेजर लाइट प्रोड्यूस होगा जब आपका E2 से E1 में ट्रांजिशन होगा, ये डिफाइंड है. That's why you are getting that almost monochromatic, but there is some finite spreading because of finite lifetime of each level. Because of finite lifetime of each level, you will get some spreading. But you can understand that why ordinary light will have many number of wavelength or broad spectrum, because there are many atomic transitions are possible from different states, and it can give different wavelength. But for laser light, this level are fixed. Whenever there is a transition from E2 to E1, only will get that laser light. That level is defined. Did you get what I'm saying?
Yes, sir.
Yes, sir.
Now, to understand that production of laser light, we need to understand that we must need to understand that interaction of EM wave with matter. We have to understand that interaction of EM wave with matter. Okay. So there are basically three phenomena we have to understand. One is known as spontaneous emission. So suppose you have a two-level system noted by E2 and E1. Okay, where E2 is actually higher state as compared to E1. Okay, now let us assume that number of atoms per unit volume in E2 level, that is N2. And on the other hand, number of atoms per unit volume at E1, that is N1. Also assume that lifetime of this E2 is tau sp, or you can mention that tau sp is actually spontaneous lifetime of level E2. Spontaneous lifetime of level E2. Okay, so there is some atoms here, right? And these atoms have some finite lifetime, that is tau sp. So within tau sp, this atom spontaneously jumps from E2 to E1. To conserve this energy of the system, what will happen when there is a transition from E2 to E1? There will be emission of photon. and the energy of this photon will be same as separation between these two levels, that is E2 minus E1, to conserve that energy, right? So since this process is actually happening spontaneously, that's why this is called spontaneous emission. So there is no need of any perturbation here. Whatever atoms is there, it will spontaneously make transition from E2 to E1, and it will produce that photons having energy that is equal to E2 minus E1. Okay, and you have to keep in mind that these atoms will jump within the time that will be the lifetime of this level, that is tau sp. Is this clear what I'm saying?
Yes, sir.
Okay. Now that spontaneous emission, that rate of spontaneous emission noted by dN2 by dt. You can mention that rate of spontaneous emission. Okay. In later, I'll tell that is nothing but rate equation. That is nothing but rate equation. So that is noted by dN2 by dt, and on the subscript you can mention that spontaneous emission. So this rate of spontaneous emission directly proportional to number of atoms at level E2, that is nothing but N2. ठीक है ना? जितना नंबर ऑफ एटम्स आपका N2 में होंगे उतने नंबर ऑफ आपका स्पॉन्टेनियस इमिशन आपको मिलेगा. Okay, but this spontaneous emission will never help you to produce high intensity. Because why? Why? Because of some reason that I'll tell. Okay, so you have a N2 number of atoms per unit volume at level E2, right? This is your E2, this is your E1, and tau sp is the lifetime, है ना? tau sp is the lifetime of level E2. इसका मतलब ये नहीं है कि भाई आपका tau sp टाइम के बाद सारे एटम सबका यहाँ पे आ जाएगा, ऐसा नहीं है. जैसे हम कैसे इसको अंडरस्टैंड करेंगे? सपोज मान लो ह्यूमन जो है, ह्यूमन का जो लाइफ टाइम एवरेज लाइफ टाइम है, सपोज मान लो 60 ईयर से. इसका मतलब ये नहीं कि सारे 60 ईयर में सारे लोग आपका मर जाएंगे. कोई 30 साल में एक्सपायर होंगे, कोई 40 साल में, कोई 50 साल में, है ना? कोई 60, कोई 70, कोई 80. सेम थिंग इज यूजेबल हेयर ऑल्सो. टाउ एसपी जो है ये आपका एवरेज लाइफ टाइम है. इसका मतलब ये नहीं है कि टाउ एसपी टाइम में आपका सारे एटम्स यहाँ से यहाँ गिर जाएंगे, ऐसा नहीं. सपोज मान लो एक आपका अभी गिरा है, then it gives photon. ठीक है, 1 मिलीसेकंड बाद एक और आपका इॉन में आया है, then it will give. एंड सपोज मान लो ये आपका इस डायरेक्शन में जा रहा है जो फोटोन इमिट हुआ है. इस ट्रांजिशन के कारण जो आपका इमिट हुआ है, इट इज गोइंग लाइक दिस. कुछ और मिलीसेकंड बाद एक और एटम का ट्रांजिशन हुआ है फ्रॉम E2 to E1. Then there is a production of another photons, but this time this photon is going like this. And this is actually happening in spontaneous emission. So in spontaneous emission, that photons are emitted, they are actually random in time and random in direction. Photon emitted by spontaneous emission, they are random in time and they are random in direction as well. Okay, so एक सपोज मान लो अभी एक इमिशन हुआ है ना, एक ट्रांजिशन हुआ है, then it create a photon and this photon is going like this. 1 मिलीसेकंड बाद ये एटम यहाँ पे गिरा है ना, then it create this photon, but this photon is not going like this, it is going like this in backward direction. Then after 1 millisecond there is another transition from E2 to E1 and it create this photon, but this photon is going like this. So photon emitted by spontaneous process, they are random in time as well as random in direction. So there is no finite phase correlation between these photons. There is no finite phase correlation between these photons. You know? So
Yes,
there will not be any constructive interference. You know? There will not be any constructive interference. कॉन्स्ट्रक्टिव इंटरफेरेंस कब होता है? जब आपका दो या मोर फोटॉन्स के बीच में एक फाइनाइट फेज कोरिलेशन हो, इस तरह की. When there will be any constructive interference, when there will be phase correlation between two or more photons. When there is a constructive interference, कब होता है? जब दोनों के बीच में phase difference either 0 हो और 2 pi हो और 4 pi हो. Then what will happen? There will be the constructive interference, and as a result there will be amplification of amplitude. There will be amplification of amplitude, and we know that intensity is nothing but I proportional to a square. है ना? So whenever there is a finite phase correlation between photons, there will be constructive interference, and as a result of constructive interference, there will be amplification of amplitude. And if there is a amplification of amplitude, there will be increase in intensity. Why? Because I proportional to a square. But this situation can never happen here in spontaneous process. You can see these photons do not have any finite phase correlation. So you can mention that intensity will never build up by spontaneous process. Why? Because of there is no finite phase correlation. Is this clear what I'm saying?
Yes, sir.
Yes, sir.
Yes, sir.
So to produce this laser light, we don't need this spontaneous emission process. आपको जितना कम पॉसिबल है उतना ही कम करना पड़ेगा, क्योंकि आपको क्या चाहिए? हाई इंटेंसिटी चाहिए, and this actually not build up any high intensity here, right? So we no need of this process to produce laser light. But this is automatic, right? ये process क्या है? ऑटोमेटिक है, but इसको आपको कम करना पड़ेगा. How will इसको कैसे हम कंट्रोल करेंगे? हम पढ़ेंगे जब हम डिस्कस करेंगे आइंस्टाइन को. Okay, then you have another process that is known as stimulated absorption. To describe this process, again I have to draw two levels, because laser light is all about two levels. So you have two levels, E2 and E1. Okay, and suppose that their population are like N2, N1. Okay, and tau SPs are a spontaneous lifetime of this process. Now suppose this is a system of two levels. Okay, and a photon having suitable energy, and that energy is h nu dash. When a photon having suitable energy or frequency, the energy of this photon is how much? H nu dash, or you can write h cross omega 0. When the energy of this incoming photon is exactly matching with that energy separation between these two levels, E2 minus E1, then what will happen? The atoms are sitting at the level E1. The atoms are sitting at level E1. These atoms will absorb this incoming photon, and it will make transition from E1 to E2. Okay. So at the output, you do not have any photon here due to this process. ये आपका जो photons आ रहा है is in stimulated emission. What will happen? This photon will be absorbed by that atom sitting at ground state, and it will make transition from E1 to E2.
सर
Hmm.
एक क्लैरिफिकेशन है. आपने भी बोला था द एटम्स विल मेक ट्रांजिशन, तो एटम्स हैं जो ट्रांजिशन कर रहे हैं या जो इलेक्ट्रॉन्स हैं वो ट्रांजिशन कर रहे हैं?
Exactly, this is a good question. Actually, when we study about atomic physics, if you know, we study about that atomic physics, है ना? Atomic physics जब हम स्टडी करते हैं, किसके लिए स्टडी करते हैं? हम इलेक्ट्रॉन के लिए करते हैं ना? जब हम एटॉमिक फिजिक्स स्टडी करते हैं, हम किसके लिए स्टडी करते हैं? इलेक्ट्रॉन के लिए ना? इलेक्ट्रॉनिक
Yes, sir.
लेवल दिस दैट, राइट? सो व्हाटएवर व्हेन आई एम सेइंग दैट एटम्स आर सिटिंग एट ग्राउंड स्टेट, इसका मतलब क्या है? हम इलेक्ट्रॉन की बात कर रहे हैं. जब इलेक्ट्रॉन, जो एटम है उसका इलेक्ट्रॉन आपका जब आपका ग्राउंड स्टेट में है, उसका मतलब एटम उसका ग्राउंड स्टेट में है. जब इलेक्ट्रॉन एक्साइटेड स्टेट में है, उसका मतलब क्या है? वो एटम एक्चुअली एक्साइटेड. So whatever you are saying, that electron actually in excited state, correct?
Okay, sir.
Now this what I'm saying, that rate of, you can mention that rate of stimulated absorption. Absorption. Okay, that is nothing but dN on by dt. Okay, so rate of stimulated absorption, or you can mention, or you can write, that is also kind of rate equation. A rate equation. तो dN on by dt, मैंने dN on क्यों लिखा? पहले वाला लिखा था हम लोगों ने, that was dN2 by dt, because एटम कहाँ से ट्रांजिशन हो रहा था? E2 से. E2 में कितना था आपका? N2 था. So for spontaneous emission, we have written dN2 by dt, because the atom actually decreasing from N2. But this time, atom is making transition or changing that atoms. कहाँ से change हो रहा है आपका? Ion से change हो रहा है. So you have to write dN on by dt in stimulated absorption. Stimulated absorption. That will be proportional to what? Number of atoms at level N1, as well as energy density of incoming photon. So U omega यहाँ पे क्या है आपका? U omega is nothing but energy density of incoming photon. ठीक है? So this stimulated absorption process actually changing that number of atoms at level ion. So that's why you have to write dN on by dt. Okay, so dN on by dt st dot abs. इसका मतलब क्या है? Rate of stimulated absorption, that will be proportional to number of atoms at level ion as well as energy density of incoming photon. Again, we don't need this process to produce that laser light. We don't need this process. Why? Because this process is actually decreasing that light, intensity of light. जो आपका light is nothing but photons, and this photons is absorbed by this process. So this process is actually decreasing that intensity of light. So we don't need this process as well. We don't need spontaneous emission. We don't need stimulated absorption, because this process is actually decreasing that intensity. Okay, is it clear what I'm saying?
Yes, sir.
क्या clear है आप लोगों को?
So please repeat the last line. What
Yes.
is that?
What I'm saying, yes, what I'm saying, in spontaneous emission, that never build up that any intensity. So we don't, to produce laser light, we don't need spontaneous emission. Again, for stimulated absorption, what is happening? You have a photon, light is nothing but photon. So this photon is basically absorbed by this system. As a result, you don't have any light at the output. So whatever photons inside that cavity, that is basically losing by this process. So this process is actually decreasing that intensity of light. We don't need this process to produce laser light. आपको जितना possible है इस process को कम करना पड़ेगा, है ना? Did you get?
E2 में ही यहाँ
Yes,
जा
sir.
रहे हैं ना एटम, सो डिक्रीज कैसे कर रहे हैं मतलब?
ये अब आपका ये लाइट है, ये लाइट है, E2 में कैसे जा रहा है? इसको एब्जॉर्ब करके जा रहा है.
फोटोन, यस.
हाँ, तो आउटपुट में आपको कुछ मिल रहा है लाइट.
हाँ.
आउटपुट में
नहीं
कुछ नहीं मिल रहा है ना. ये
हाँ,
प्रोसेस आपको चाहिए नहीं चाहिए?
क्लियर सर, थैंक यू सर.
So you can mention that this process is not suitable to produce laser light. This process is not suitable to produce laser light. Then you have only one process, that is stimulated emission. ठीक है ना? So you have to keep in mind that ऐसा नहीं कि कोई frequency का आपने photon sign कर दिया और उसमें stimulated absorption होगा या stimulated emission होगा. कब stimulated absorption या emission होगा? जब photon का जो energy है, that should be suitable, and that should be matching with what? Energy separation between two levels. That then it can, then only there will be stimulated absorption or stimulated emission. You have to keep in mind. ठीक है ना? क्या क्लियर है मैं बोल रहा हूँ? हाँ, और ये जो दो प्रोसेस है आपको जरूरी नहीं है लेजर लाइट के लिए, दे आर बेसिकली डिक्रीजिंग दैट इंटेंसिटी ऑफ लेजर लाइट. ओके, I'll tell you then later it will be understandable. Next जो process है that is what? Stimulated emission. ठीक है ना? Again you have a two system same with your E2, N2, Eon, Anon. Okay. Now suppose you have atoms here. Okay. You have atoms at level E2. Now when a photon having suitable energy is incident on this system, when a photon having suitable energy, and that energy is how much? H cross omega naught equals to H nu naught, and that should be equals to curve. This photon, incoming photon should have suitable energy. When that energy that is matching with energy separation between two levels, E2 minus E1, then this photon will stimulate this system. This photon will stimulate the system. As a result, what will happen? The atoms at level E2 will jump from E2 to E1. As a result, you have this incoming photon, it will be as it is. And due to the atomic transition from E2 to E1, you have an additional photon. So when a photon, incoming photon having suitable energy, that is E2 minus E1, this incoming photon will stimulate that system. Okay, will stimulate that system. As a result, what will happen? Atoms at higher state will make transition from E2 to E1. And due to this atomic transition, you have one photon and this incoming photon as it is. So as a result, at the output, you have two photons. You have incident one photon, but at output you are getting two photons. Okay, and these two photons are actually producing at the same time. These two photons are actually producing at the same time. They are producing at the same time, so they will have zero phase difference. So what does it mean? These photons have zero phase difference, so they will make constructive interference. They will make constructive interference. As a result, there will be amplification of amplitude. Okay, there will be constructive interference. That's why I use plus sign, and there will be amplification of amplitude. And we know, again, I'm writing same equation, I proportional to intensity, I proportional to A square. So when there is an increase in amplitude, obviously there will be increasing in intensity. Okay. So this process, you can clearly see from here that this process is actually enhancing that intensity of light. This process is actually enhancing that intensity of light.
Sir,
हाँ,
मतलब जो हमने इंसिडेंट किया है वो यूज ही नहीं हो रहा है, वो वैसे के
this
वैसे.
actually in layman language, what is happening? This incoming photon is shaking that system. जैसे आपका सपोज मान लो पेड़ पे फ्रूट रखा हुआ है ना, फ्रूट है, सपोज मान लो एप्पल है, उसको शेक करोगे तो फिर क्या होगा? गिर जाएगा ना. Same thing is happening. This incoming photon is actually shaking that system. This will oscillate this atom. As a result, what will happen? It will make transition from upper to lower level. तो ये आपका यूज कैसे होगा? ये तो अपर लेवल में है ना, आपका एटम्स कहाँ पे है? अपर लेवल में है ना. सो व्हेन दे वर जस्ट, ये क्या कर रहे हैं? सिस्टम को शेक कर रहा है ना. जैसे आप सपोज मान लो आपका पेड़ पे फ्रूट है, इसको शेक करोगे फिर क्या होगा? दैट विल बी जंप, नीचे गिर जाएगा. When there is a jump from upper to lower level, there will be emission of photon, and a photon आपका as it is ऐसे रह जाएगा. Okay, in layman language, you can say these two photons are producing at the same time, so they will have zero phase difference, and when there is a zero phase difference, there will be constructive interference. As a result, you will have amplification of amplitude, and if there is an amplification of amplitude, obviously there will be increase in intensity because I proportional to S. And if you remember, why there is a low divergence in laser light? Because these two photons are producing at the same position. These two photons are producing at the same position. As a result, what is happening? Their wave function is actually overlapping. Their wave function is actually overlapping. So this you have to keep in mind. In stimulated emission, you have two photons. These two photons, in layman language, you can say they are producing at the same time, and they are actually at the same position. When they are actually at the same position, their wave function will be overlapped. So these two photons will have a single wave function. Okay, and a single wave function can only describe a single direction. That's why these two photons will always travel in the same direction. That's why you will have low divergence. क्यों? क्योंकि उनका जो wave function है, they are actually overlapping. So they are basically describing a single wave function, and a single wave function can travel only in a single direction. They cannot describe two directions. Okay, so that's why they have no chance to go in other direction. Is this clear what I'm saying? This part is really important.
Yes, sir.
Sir, I have a
Yes, sir.
question. That if there are N1, if there would be N1 atoms in the E1 and the N2 atoms in the E2, and a photon आता है, then what will happen?
This is a good question.
Stimulated emission or absorption?
Let me complete. So before that, I have to complete that rate of stimulated emission dN2 by dt. dN2 by dt stimulated emission. That will be proportional to what? That will be proportional to number of atom at level E2 as well as energy density of incoming photon. dN2 by dt, that will be proportional to number of atoms at level E2 as well as energy density of incoming photon. Now, probability of stimulated absorption. P on to मतलब क्या है? Atom on से 2 में जा रहा है. Probability of stimulated absorption is same as probability of stimulated emission. दोनों का probability क्या है? Same है. कब? मतलब सपोज मान लो आपका इॉन में भी एक एटम है, E2 में भी एक एटम है, और यू आर साइनिंग ए फोटोन. एक फोटोन को आपने साइन किया कर दिया, तो उस टाइम जो है आपका प्रोबेबिलिटी ऑफ स्टिमुलेटेड एब्जॉर्प्शन जो है दैट विल बी सेम एज प्रोबेबिलिटी ऑफ स्टिमुलेटेड इमिशन. ठीक है ना? कब? जब दो लेवल में आपका क्या है, बराबर एटम है, तब आपका दोनों का प्रोबेबिलिटी सेम हो गया. मतलब दोनों का प्रोबेबिलिटी सेम हो गया. बट आपको क्या चाहिए, कौन सा प्रोसेस चाहिए आपको?
सर 2 से 1 जाने का.
स्टिमुलेटेड इमिशन
तो ज्यादा चाहिए ना, तो उसके लिए आपको क्या करना पड़ेगा?
टू ज्यादा रखना पड़ेगा.
ऑफ कोर्स. तो आपको क्या चाहिए, सबसे ज्यादा से ज्यादा कौन सा प्रोसेस चाहिए? स्टिमुलेटेड इमिशन. तो उसके लिए आपको क्या चाहिए? N2 को ज्यादा चाहिए एज कंपेयर टू N1. Although the probability of stimulated emission is same as stimulated absorption, but इसका मतलब रेट किसके ऊपर डिपेंड करेगा? रेट किसके ऊपर डिपेंड करता है कि कितना नंबर ऑफ स्टिमुलेटेड इमिशन होगा, कितना नंबर ऑफ स्टिमुलेटेड एब्जॉर्प्शन होगा. दैट विल बी डिसाइड बाय दिस फैक्टर. सो यू ओमेगा वाज सेम फॉर बोथ, बट एक में जो स्टिमुलेटेड इमिशन है N2 के ऊपर डिपेंड करता है, स्टिमुलेटेड एब्जॉर्प्शन किसके ऊपर डिपेंड करेगा? N1 के ऊपर डिपेंड करेगा. आपको स्टिमुलेटेड इमिशन ज्यादा चाहिए तो N2 को ज्यादा करना पड़ेगा. सो N2 शुड बी ग्रेटर देन N1 to get a higher number of stimulated emission compared to stimulated absorption, and this condition is known as population inversion. ये आपको करना ही पड़ेगा to produce laser light. क्या clear है what I'm saying?
Yes, sir.
Everyone, Kanchan,
Yes.
is this clear?
Yes, sir.
It is time now. कोई डाउट हो तो पूछो. This was like a basic thing. Tomorrow I'll be a little fast. If you have doubt, you can ask me.
सर एक डाउट है सर. हेलो.
हाँ, yes, yes.
सर नॉर्मली किसी भी एटम के अंदर अगर जो ग्राउंड स्टेट है तो ज़्यादा से ज़्यादा electrons they will try to reside in that ground state. So how will we achieve this condition when N2 will be greater than
That is
N1?
known as, next class I'll discuss, that is known as pumping process. You have to use pumping source to pump that atom from E1 to E2. Okay.
Okay. Okay, sir.
Okay, I should stop.
Sir,
Yes, you have a question?
actually, we at every time we are assuming that an atom moves from N1 to N2, N2 to N1. So, is there is possible middle levels are there or something that's what always the flow in that manner only?
That is known as actually virtual level. That is possible, but that thing I used to teach in in Raman effect. You know, that is virtual level. That may be possible, but this thing actually for laser light, I mean, we have a special type of material. So this process is not dominated here. Only few material that they showed they produce, they can be used for laser light. And for for this system, I don't think so that there will be virtual level is possible there. In Raman material, Raman active material, this state are possible in between E2 and E1. There is possible. In not only that, above E2 also there are states that possible. I'll discuss during Raman effect. Okay, but for this I don't think.
Okay, sir.
Okay, okay, I should stop here. You have already time over. Okay.
Thank you, sir.